Okay, here we are at the Dutch national flag problem. So let's give this a read through. Given an array containing zeros, ones, and twos, sort the array in place. You should treat numbers of the array as objects, hence we can't count zeros, ones, and twos to recreate the array. The flag of the Netherlands consists of 3 colors, red, white, and blue. And since our input array also consists of 3 different numbers, that's why it's called the Dutch national flag problem. Sort the array in place given an array containing zeros, ones, and twos. So we got 1, 0, 2, 1, 0. Okay, so we have to... can't count them. So it wants us to swap them in place. And here we have some examples, 1, 2, yep, our example cases that will output. So so right now we return just the exact array that we already have. It's a bit cramped on here. I can't really zoom it out without zooming the whole editor out. That's fine. Okay. I'll just do one at a time. So, Dutch flag sort. This, since it's a 2-pointer problem, means we're going to need 2 pointers. Now, let's see. The way I'm thinking about doing this is starting here. So we have our array. So 1 pointer is going to be pointing here at our first index. Okay, so right, we're gonna have one pointer here, and then the other pointer. So we're gonna know about the value 1. Our next pointer is gonna search, and it's gonna search, so it's gonna find a 0, which is smaller than 1. So we're gonna look for the smallest value we can, I think. So let's see. So we find a 0. Now what do we do if we find a value smaller than 1? Do we swap them? So I is equal to 0, j is equal to 1, and array I at 0 is equal to 1, and array j at 1 is equal to 0. So if I swap these values, they'll be swapped, and then what happens if so my I is still here and I got a 2. Ooh. I'm not quite sure how to use 2 pointers off the top of my head to solve this. Consistive, okay. So 0, 0, 1. Then I get a 2. Then I get a 1. Then I get a 0. Sort in place. All right, I'm thinking. So if we have j here and it's a 0, what should I do if I find a value less than 1? I should swap it. And then what should I do? I should move J here. When J, so we move J, so we swap and then move J, or right value to the right. Now I find a 2. What do I want to do with this 2? This I value used to give us 1, and now it gives us 0. Okay, let's see. The brute force solution will be a heap sort. So let's just go make sure we know what a heap sort is. Heap sort is a comparison-based sorting technique based on binary, blah, blah, blah. Stinky. Haha. Poop. Let us divine how to build the heap. Oh my god, bro, I don't care. Show me an animation. Build the heap. Create a max heap. Okay, well, that's the naive approach. We can use 2 low and high, the first and last element of the array respectively. So while iterating, we move all 0s before low and all 2s after high. Oh, so that in the end, I didn't consider the 3-pronged nature of this problem. The fact that we only have 0, 1, and 2. I see. So let's think about this. It wants us to use low is 0, and high is equal to, we'll say let k equal to array.length, so we don't have to write this out a million times. High is equal to k minus 1, because length off by 1 error. It's obvious, bro. Think about it. Do we want a for loop? Yes. So for I equals 0, I is less than k, I plus plus. Now what do we want to do? If array I is equal to 0, then array.unshift array I. Will this move the element? Yeah, it should. It should. Unless there's like a move thing. Well, let's see. If array I is equal to 2, then array dot shift array I. So why is this a 2-pointer problem? What am I missing? Okay, low, high. All right, what the heck is going on here? 0, 0, 0, 0, 1, 0, 2, 1, 0. 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, let's see, remove one element. The shift command will remove the first element of the array. Oh. The unshift will add. So I don't want shift. Splice, okay. Array dot index of let array equal element I. So okay, we need to save this before we use it. We'll splice it and then put it to the beginning of the array. How do you put something on the end? Push puts it on the end. Okay, yeah. So let's copy this. Actually, okay, what happens here? 0, 1, 1, 0, 2, which there are 2 zeros, 2 ones, and 1 2. So almost, that almost works. Let's output the array every step and let's look at it. 0, oh, we got more. Okay. One, 0, 2, 1, 0. So this is how we enter. Then we get 1, 0, 2, 1, 0. Nothing happened, but we went here. Something should have happened here. Oh. Okay, well let's get the returned arrays then. So first we swap these, then we come to a 2, so we put the 2 at the end. We move all zeros before low. Well, let's look at this goddamn solution then, because I'm a little stumped. Not gonna lie. So they did the same thing we did here. Low 0, highs k minus 1. While I is less than high, if array is equal to 0, then array I and low. Swap. Increment I and increment low. Oh, I see. Let's just try this again, shall we? So let's try this. I is equal to 0 while I is less than k. Less than or equal to? I think just less than. While I is less than k. If they're the same? Yeah, if it's equal to 0. I see. So if array I is equal to 0, what do we want to do? Well, we want to swap low and the array value. So this is actually a syntax I learned at Python, but if you do a comma, you know, you can swap values around on a single line without needing to use a temporary variable to do it. So that's pretty awesome. Okay, so if it equals 0, we want to swap with this. Else, if we're equal to 2, then what we want to do is this, but with high. We also want to say I plus plus, low plus plus. High minus minus. So what do we have now? We have an infinite loop. One zero two one zero. So we didn't change anything. That is perplexing. Let's just take another quick peek here. Oh, we don't want to swap it if it's high. We don't want to do I. We don't want to increment I if it's high. That's interesting. I guess that makes sense, yeah. So else I plus plus. What happens now? Nothing, because this one doesn't do it. What about less than or equal to k? Still nothing. Oh, this format is interesting. That was not the case. Dude, our code's identical at this point. Isn't it? While I is less than or equal to high. Oh, well. That's not going to do it though. What? It did it. But it didn't return what I wanted. Oh. Okay, so I thought I understood this. Does this swap the two arrays in place on the... Wow, okay. So let's think about this then. What is going on here? We have this array. We have a high and a low. So high or low is equal to 0. High is equal to 0, 1, 2, 3, 4. High is equal to 4. So we start on 1. And if we're equal to 1, we just move to the next element. And low is still 0. So low is over here. Now we get to a 0. And what we say is we want to swap these two values in place. So boom, boom. And now low is 1 and I is 2. So now I is here, low is here. And we're at a 2. And so what we want to do with the 2 is move it to high. And then subtract 1 from high. So this now becomes 0, 2. High becomes 3, and we don't increment I. So now I is still 0, or it's still 2, and we get a 0. And so for a 0, we swap low with 0. So now low becomes 2, and I becomes 3. So now I is here. All right, and now we have 1, so we just move to the next one, and we're sorted, and that's it. So let's, I must have deleted the other problem, but let's just print out the other one, and that one works as well. So I did not do much solving on my own that time, but now I better understand, and I hope you better understand, how this thing actually functions. Cool.